Okay, let's take a look here. Oh. So real quick, let me show you. Everything I showed you earlier, I'll actually do it with this data. Okay. So then L2, see how I have L2 highlighted? And I want L2 to be everything in L1 minus 6.5 in this case. X bar is 6.5. N is 12. Different things. Now this is not in order. Just, a lot of you guys put it in order, but this is the same kind of numbers you guys saw. And then I go to L3, highlight L3. Now watch, if I just put it right here and I just try to say, I want this to be L2 squared, look at the error I get. It's called data type, because I'm trying to put an entire list in one spot of a list. So it's like, holy shit, that's not the right type of thing. So I go, oh, I'm sorry, little calculator. Go up to, I've got to delete that. Go up to L2, or L3, and now I can put in here, L3 is L2 squared. Kabam. I lock it. But do you ever actually have to do this? Not really. You could just do each one, but you can understand how that wastes time. Now, if I sum up, so I can go to my lists. I'm going to get out of here. Go to my list, and I can hit sum, and I can sum up like L2. If I sum up L2, it should come out to be 0, like we talked about earlier. Thank God. It close to 0 if you had to round anything. And then I can do sum. Oh, here's something really cool about this calculator. Hit second, enter, and if you do it a few times, see how it's just bringing up everything I did before this? If I hit second, enter, it'll bring up the last few things I've done. So hit second, enter, and now I can go overwrite L2 with L3 because I want to add up L3. Is everybody semi with me? Hit 69, so that's, this guy adds up to 69. So anywhere I see this, what did I just say the value of it is? 69. So where do I see it? Right there. So I just replaced this whole damn thing. You never put something here. That doesn't make sense. What is X? All of these. So how would you put something here? It doesn't make any sense. This whole thing is 69. N is 12. That'll be 11. And sure enough, 69 divided by, got there. So 69 divided by 11. Is that business? Yes, sir.
Why did you not do n minus 1 on
I did.
You did?
What's n?
The number of...
In this case, it's
X's.
what? What number? What is n? What is n here?
12. No, but on the example on the board, where it says n for variance.
Okay. So again, this is a variance for a what? Population. So I don't need the sample adjustment. This is the sample adjustment. And here we know it's a sample because I say sample. If I don't say, you assume it's a sample because that's pretty much what we always have in statistics is a sample. Okay. So now on your paper for the variance, you can certainly round this to like 6.27 even if you want to, but I want to show you how you don't have to round shit in the calculator. What's the next thing I want to do with that number? Square root it. So one of the most useful buttons on this calculator is right above the negative key, ANS, and that stands for the answer on the screen. So it's a memory location, and it changes as the number on the screen changes. So right now, what is in that memory location? This number. So if I said take the square root of the answer, it will square root that number. I don't have to round it. I don't have to waste time writing the whole damn thing in there. Kabam. That's going to be really useful this semester. So 2.50 5. Please, dear God, round it for real. Yes. Oh, yes. Okay. Let me go back up here. If I had second enter, it takes me back up to there. And now if I do square root, so second squared, you get square root, right? It's above the square root button. Above the square button is square root. Square root of answer. Come in. No, okay. So there's your square root button. And there's the ANS button right there. So if you do second squared, you get square root. Square root of what? Square root of the last answer on the board. So second negative to get answer. It'll be the square root of that answer. Enter. Bam. Do you have to do that? No. What? Huh? Sure. Oh, I see. No. Second. Now hit negative. See, I mean, when you hit second, it's in the shift.
Still just struggle.
Okay. So what is that? What is that right there, that number? Don't read it off. It's the standard deviation. I like it. So 2.505. And what does that mean? What does 2.505 mean?
The standard deviation between those numbers is
Yes, I made it 3 decimal places. You can make it 4 decimal places, even better. Yes.
How many numbers do you put after the decimal? Just 3?
Standard deviation always has to be at least 3 places. So if you make it 4 places, that's fine. Make it 2 places, that sucks. You're losing points.
Okay.
So that number represents the average distance from the mean to every data point. So on average, the data points get 2.5 away from the mean, both directions. So if I had another one that had a spread of 5, it's like twice as spread out. They get twice as far away from the middle. Okay, I like it. Now, let me ask you this: if every step I take is 2.5 feet, and I am at the number 10 right now, where am I when I take 1 step? 12.5. I like. So how many steps will it take to get to the number 14? Will it be a whole number of steps? If I'm at 10, every step I take is 2.5. If I want to get to 14, how do I figure out how many steps it's going to take? Well, how far do I have to go?
1 and
14 minus 10 is 4.
yeah, but it has to be 1 and
Stay with me now. This feels a lot like class width. I want to see how many steps fit into the distance I have to go. And what does it mean when I say fit into in math? Divide. So if I take 14 minus 10 divided by 2.5, that tells me how many steps there are between the two. So this, the S is what scale I want to use. Do I want to use inches, centimeters, miles? And I base it on how spread out my data is. That kind of makes sense. Like we were saying earlier, I'd use inches between people, but I would use miles between cities. Because cities are more spread out than the people in this room are, for damn sure, right? I mean, it's obvious. So the S gives me kind of a feel for how spread out things are, and the Z-score uses these to measure how far apart things are. So if I see how far apart is the data point from the mean, how far apart are they, and I divide it by standard deviation, it'll tell me how many standard deviations fit between the two. So what does the Z-score always tell me? The number of standard deviations from the mean to a data point. Sounds like a note. Z-score tells me the number of standard deviations from the mean to a data point. So can a Z-score be negative? Yes. That just means you are below the mean. So if you got a test back and your z-score was -2, that sucks. You're 2 steps below the average, right? And a step size for quizzes and tests is normally about 14. So that'd be 28 points below the average. Shit. So you want a positive z-score in that case. So in this case, what's the data point that I'm interested in? That's what x represents as data points. Which one am I interested in? 10. What's the x bar? 6.5. And how big is the standard deviation? So I call standard deviation steps because that's the size of my step I want to use when I'm walking around in my data. If my data is really tiny, I'm going to use little tiny steps. If my data is really spread out, I'm going to use big ass steps and get around the damn data. If I use the big ass step for a tiny data, I miss the whole damn thing. It's like blinking and you miss that town that's on the freeway. You know, when they have the speed limit go way down and they have it go really back up. Anybody ever went on a big road trip? Okay. So what do you get here when you do this?
139.7.
1.937? That's that. So we'll talk more about z-scores later in the semester. Down here, I love this question. What percentage of the data is within 1 standard deviation of the mean? Now, within, that means up and down. If I said guess my weight and you have to be within 10 pounds, well, if you're over 10 or under 10, I'd say you got it. I'd give you that much leeway, right? So in the middle, I'm going to put the mean, still 6.5. What's 6.5 minus a step? Minus 1.397. Yeah, what do you get? 5 point. Good. And if I add 1.397, now what data points do I catch if I throw that net out? Do I catch any of the 5s? Nope. But because the 5 is out here, right? I catch the 6s. I catch the 7s. Do I catch any more?
I thought you were supposed to be using metric. So the 2.5.
Oh, I'm sorry. Thank you. There you go. I was looking in the wrong place. I love you guys. I love you guys.
I don't know, I'm so confused.
Well, then tell me. I said this. I think I said this before. I love you guys. I'm a human being. I make mistakes. So just let me know. So 2.505. Thank you. I love it. Just speak up. It's not a big deal. So what is 6.5 minus the 2.505? Who is it?
3.995.
995? I love it. And what's 6.5 plus 2.505?
9.00.
9.005. I love it. All right, now we catch a lot more than 6 and 7 now, right? We catch, what's the lowest thing I catch? The 4s. And I can definitely catch the 5s, the 6s, the 7s, the 8s, and the 9s. So the only things I don't catch, the only things I don't catch are the 10s and the 2. Everything else is in there, right? So how many data points did I catch then? I caught 9 out of 12 data points, 75%. There's a theorem, I don't know if I've said this word yet, this phrase. The bell curve.
Can you zoom it out? Right.
Oh, sure. So the bell curve. In the bell curve. So the bell curve, whenever you hear somebody say curve the grades, I think I told you this, they just move the curve around. So a bell curve is also called a normal distribution. So like heights do this. You would expect that somebody would have a height somewhere close to the average, and then out here, really tiny and really tall, you wouldn't expect that. There's very few people out there. Within 1 step, within 1 standard deviation of the mean in a normal distribution, there's 68% of the data. So this is a theory about normal distributions. This one, what did we find? We found 75% of the data within 1 step. So it doesn't sound like it's close to normal. Right? It should be 68% if it's normal. Okay. So I like to ask this question because it's related to some of the theorems about how much data is where. Like it. Cool. So let me solidify a few things, and then we'll head out. So let me also say this. I don't know if I've said this yet, but for every test, we will have a formula sheet that we'll create on the review day. I don't make you memorize every single formula. I do make you memorize a few. So we'll make it really clear which. But I do make you recognize that you can't put any words on your formula sheet. Just formulas. Okay? Don't tell me what past teachers have done to you. I don't give a shit. We have this formula right now. We just talked about it. What do you think it looks like for a population? What would I change for a population? So instead of x bar, I'd have mu. Instead of s, I'd have not s, but what? What's the Greek letters? Not s, but sigma.
Yeah.
So the formula's idea does not change. It's what we're interested in minus the middle divided by the spread. That's what it is. Yeah, I like it. So if I told you the mean is 11, the standard deviation is 2.8, what's the z-score for x equal to 9? Can you do that? What would that be? Is it going to be negative or positive? Can you tell already? Where is that related to the mean? Is it above it or below it? It's below it, so it's going to be negative. If it's below the mean, it's negative. If it's above the mean, it's positive. So now all you got to do to figure this out is plug and shove shit, right? We got the formula. And this tells me the number of standard deviations from the mean to that data point. It is a measure of distance. It's how I measure distance in statistics is z-scores. So they're a huge part of this course, are z-scores, right? So this would just be x minus the mean divided by the spread, and whatever the hell that is. 5/7 is about 0.7 something. Nobody's going to help me out? You're just going to... Who is it? 1.071. 1.071. I'm pull that. It's late in the day. And it should be negative, right?
Negative 0.714. Yeah.
That sounds better. Negative what?
0.714.
That was closer to what I thought it should be. All right, I like it. And be careful when you put this in your calculator. You've got to tell it that's the top. How do we know it's the top? Because we got eyeballs. We can see that big bar. Calculator doesn't have eyeballs yet. We don't want that because then the next thing is Terminator and all that kind of shit. Last thing. What if I told you this? The z-score is negative 1.68. The mean is 42, and the standard deviation is 11.91. What's x? Good. So the very good idea. I love this shit. This is why you learn this in algebra. There is a reason for algebra. It's crazy. Can I solve this for x? Of course you can. It's not that hard. What's the worst thing about this if I'm trying to solve for x? The stupid thing on the bottom. So the first thing I do is kill that. Right? How do I kill that? Multiply both sides by sigma. Dead. And then I add the mean. Right? So you get x equals mu plus z sigma. So if I just plug this shit in there, I'm going to figure out what x is, right? I'm not even going to do it because that's easy. But now look what this says. How do I read this in English? This is just another language. Can I translate this to English? Yes. Star the mean. Watch, go with me. Start at the mean and go this many standard deviations to get to the data point. The data point is this many standard deviations from the mean. That's what that says. If I start at the mean and I go this many of these, I get to the data points. This is a definition of Z-score. Every single test I give you, I'm going to ask you a variation of the question, what does a Z-score tell you? I tell all of my stats students this. You always want to know exactly what's on the test. I get maybe 60% of people get it right at best. And I just told you the answer. What does the Z-score tell you? The number of standard deviations from the mean to a data point. Do you have to say it exactly like that? Please, no, I'd love it if you could just tell me the idea. Know the idea and you won't go wrong. Try to memorize it and you're just going to have a bunch of words spilt out of your mouth. I know this word's there. No, that doesn't make any sense. Yes, ma'am. Yes, sir. Say what? Oh. A Z-score is the number of these. Yeah, because it's multiplying. So it's the number of standard deviations from the mean to the data point. So that's how you say that math sentence in English. Okay. So come Monday, I'll have the practice test with an answer key.
Next Wednesday.
Yes.
This
What do you mean? This coming Monday. Not the Monday that's already happened. This is freaking me out. Yeah.
just the money that's very close.
So like how it goes.
How about yours?
You can write the Z-score, but you can't write.
Oh. Don't worry, we'll get like a little study group.
Yeah, and hopefully Jeff is
What's that?
not too busy watching the Boston League.